I think we had a lot of interesting talk. I will keep it little light, so there are less technical content and more about what we are trying to do. It's a work in development. So by the way, I'm presenting this first time, this work, and the slide is formed in the morning, so expect some errors. Okay, so let me start with my introduction. So I'm Vivek Gupta. I'm a newly minted professor, 2 years in ASU. I am from computer science department. So I do work on AI. I'm from natural language processing. That's my background. So I'm doing AI for now 8 to 10 years. My group name is Coral, which was one of the title talk also, and it's called Coral Lab. So today I'm going to present about game, education and AI. So I will discuss a platform which we are trying to build, GamED.AI, which try to basically bring these three things which seem like very different, AI, education and game, together. And the goal is, as you have seen, like with AI has a huge disruption in the education thing. The assessment we do, the learning is we do, now they are all changing. So learning material are becoming more innovative, curriculums are being designed by AI. Student on the other sides are using AI to bypass cognitive learning. So for example, assessments and other things, they use AI to complete it rather than doing it by themselves. So there are both plus and minus sign of how AI is coming into education. So is there anything we can do interesting, and maybe game is the answer to it. So I will discuss the GamED.AI platform, which is the platform for automatic educational game generation using a multi-agents framework. So agentic AI, are you all aware of? So basically in Crux, what we do is we try to see if we can convert education content into games, and then student can work on those games and have cognitive things. And in this process, we also bring components of education like pedagogy, Bloom taxonomy, so that it's part of the internal game design, so that we have better learning opportunity. So let's see, is games really useful for traditional learning? Are they really beneficial? So first of all, like games has a huge effect size. So you can see that 0.67 to 0.96% people are involved in STEM and mobile-based learning platform. Secondly, games led to higher performance. They increase the performance by 20%. This is published results. Games also had a higher knowledge retention. So if you have a gamified way of learning, then you retain 50% more knowledge than if you don't have a gamified way of retention. Then they also have a higher engagements compared to if you teach in a slide-based fashion. So higher engagement around 60%. First, and also games are very addictive. So I have seen this in a positive way. So people go to levels, they level up, they achieve goals, they get reward, and that, if combined with education, can have a more benefit aspect. So 200% time, there's a higher completion rates for games. People try to finish games if they go into it. And then it's also shown in industry reports as something which is gamified as 90% more onboarding rate. There is also scientific evidence about why game is better than read. So you can see if the game is there, then you have more prominent areas of brain which are activated. But if you just do a reading kind of thing, that doesn't have. So you have seen that there is different aspects. For example, when you have visual aspects, you learn better, which is 47%. But when you have gamification, it's even better. It's 60% more retention, more better approach. So educators are using various approaches before also to improve learning. So they have goal setting, they have creative expressions, they have real world relevance, they have discussions or student engagements. But we found that games is much better approach and cover many of these things in the design itself. So it can help in education much better. So we also see that after gamification, before gamification, many of the metrics which people evaluate education on actually improve. This is a tested thing. And it also help in the, so if educators say, okay, there's a common concern which parents might, I spend my students to learn, not to play games. This is a common thing. But if you look at this metric, they actually help you in learning much better. So the engagement factor improve, the attention focus improve, they participate much more, they complete tasks more, they have more motivation to learn and do things. So compared to traditional pedagogical techniques, this is a much better way of educating, or much newer way of educating. Now also, this is a good thing we discovered, we also want to see how this fit in current market trends. So gamification in education is a huge market. It's around 2.5 billion to 8.28 billion things. Game-based learning, there's already around 6.2 billion, is expected to grow to 17.8 billion. And in the edtech overall, which is a huge market, around 187 billion kind of thing. So there's a lot of opportunities of how games and education can come up together. Okay. Now let's discuss what's the problem with current. So it's not like game and education has not been rethink before. So they are, you have heard of quizzes, booklet, Kahoot, GimKit, Quizlet Live. So they already are there, which are trying to do education combined with AI, with games, but they are more, there are a lot of issues around them because they are not designed in the pedagogical and the education side. They are designed more for no gaming angles, but not in the education learning aspects. So they have very limited interaction times, like category bottlenecks. So they are MCQ, flashcard, or forced templates which are there. Many of them are engagement, which are more engagement oriented rather than learning. So they are not focused on the learning aspect. Many of these platforms are expensive, so there are free features which you can do, but then the paid features are very expensive to do. These are started to now use AIs for doing things. For example, they give a prompt and then generate some games, which is okay, but they are not designed from the education angle properly. So we at the GamED.AI try to see what we can do better. So we actually studied what are the games people play which are useful and all, and then created 40 plus composable interactions. So how, like a drag and drop, ordering of things, if putting things in images, clicking string, a lot of 40 plus interactions, and come with 4 template families which we are expanding now. We look how of these are involved in the pedagogical depth, which is important for education. How can they align with the learning objective, and how they can be also racked in, so they can be grounded in a curriculum. So let's say as a professor or teacher, I posted my curriculum or something, I want the game should align to that very well. So which we want to have. So they should have a aligned objective. Also, we want them to low cost so that we can afford. Many people in community college, K-12 education cannot afford that. So we want to build games first faster in times. So let's say tomorrow I'm holding something, I don't want like 30 minutes to code, or I don't want a game developer to be hired to do it. So I want it faster and in lesser time. Also, anything which we do with education, children, or specific K-12, we want to have a control. So there should be always human in the loop, or any places where verification can happen to see if things are going in the right way. So there are 3 basically current landscapes which you look at. One is the learning platforms, which are basically quiz and flashcard tools. They have limited mechanics and no pedagogical AI. Then there are the second category which has AI in it, and or they have human involved in it, but they are limited in multiple ways. They are expensive, they have more times to consume. And in the GamED.AI, we basically use AI, but in a multi-agent setup. So we have small AI working in very agentic fashion with control and verification, with human in the loop, to generate custom multi-interaction games. And each games we can generate in much faster, like 5 minutes, and they cost us much lesser. So we don't know the actual cost of how these games are, but these are the prices which they offer. This thing. So how high level how GamED.AI work is, there's a teacher who has a query, there are some source files, subject matter, learning goals, and grade levels. So for example, if I'm teaching NLP, I say I'm a professor for NLP, this is the topic I'm teaching, this is the slides, or this is the content which I'm teaching, I'm matter of this is the undergraduate class, and my learning goals for this topic is this, or for this class is this, and this is what I want to have my students to have grade above this, or they understand this concepts really well. And the output is basically you get something like a learn modeable game which has a test mode, and test mode is where you can do testing, and a learn mode where you can do learning. So for example, in quizzes and all we do learning, but in assignment we want to test the student, and then it should be able to integrate very well in current LMS platform like Canvas, Moodle, others, and it should be playable and kind of fun also, so that students have more engagement and learning. So how it works is we first have a planning phase, which do a rack grounding, so whatever the input teacher gave, plus the LLM knowledge, plus the pedagogical alignment, knowledge of how education work, how teaching work, together to generate a plan, high level. Then it goes to a generation level, which is a system of multi-agents, which took that feedback and then choose the appropriate templates, interactive elements, and then come up with a game design. And then finally, all of the designs and elements are assembled together, they are tested out, humans can verify, and then finally we get a LMS ready delivery of a game. So let's go over this. So there are five phases from questions to a playable game generation. So first is you input, which can be a natural language query or a file upload, which a professor or student can do. Then you have an AI dashboard, which you can see all the systems and agents which are working around, which basically now make the plan and implement those plans which you get. Then you have a human in the loop alignment, which can also look at the agent and give feedback, but it also have a chat element where real-time chatting you can do. For example, I have a game, but I didn't like this part of the game or this part of the thing, or maybe increase the level in this way. So many times I did generate small games for my classes using just Claude and all. But then I say, okay, this question is good, but this is not good. Or this, sometimes I generate game with like the trivial answer already there. So I change that. So sometimes human steering is needed to get to the right. So there's a real time chat which can basically affect each of the component, and then you can have a changes as required. And then finally you have a playable game. Now if you're satisfied with the playable game, it can store in your game library, which you can use for future classes or other aspects. So we tested this on evaluation aspects with other models like sequential decision makings or reason plus act kind of agentic approach. We find that the GamED.AI is much better in the architecture performance. Small agents doing particular tasks trained for that. It's 90% more validation results, and which is around 17.5% better than the React and 33.3% better than the sequential approach. We also find this is much cheaper. Like for example, we give the same, like we ask a person to make a game for a particular question using just Claude code, and it took them multiple iterations and came to the thing, but then the token amount, the code, the cost required to that game was much higher than using a GamED.AI, where he just choose the element and then put out the game and they get much faster. It's more than the React and the sequential in the cost, but then the quality of the game you get is much better with much cheaper cost. So we also have much better token efficiency, so we don't use much of your API calls compared to React or Claude, but it's more than sequential, but then the quality of the game you get is better than the others. So current platform, we have basically on-demand generation, so you can give your query, upload topic, playable games. You have human in the loop configuration, so you can steer things. You have real-time observability, so you can see exact pipeline, what happened in each of these. There's a verification stage. I can go in more technical later on, but if you want to know exactly what the pipeline is, but you can see the dashboards and see how much cost they take, what is the latency, what is the thing, what is the input, what is the output. You can have a module upload plus RAG, which you can use. And then you can obviously integrate this with LMS. This is something we are still working on a bit. We have integration, but it's not smooth right now. You can use open source LLMs as well as closed source LLM. That's the good part. And then we also want to, we have taken care of some of the education compliance, FERPA, the accessibility and all those things, which are needed if you want to release this as a training thing and all. Future, all the games right now are like kind of 2D, not 3D. They are limited templates, so we are trying to improve on that. There's no multilingual support kind of thing. And then obviously we are not having evaluation, and some of the thing, like the plan is also like, for example, if somebody play a game, we want to know where he make the errors. So I, as a teacher or a professor, I can know why the student didn't learn this concept, or why he particularly made error in this particular question. What is the error he made? So if that can, I have a feedback, I can give back some more things. I can show you a quick video. Let me see. So if the audio is there, let's see.
It transforms any educational question into a fully playable interactive game. The system supports 15 game mechanics across multiple domains and 3 educational levels. Let's see it in action. We enter a question, label the parts of a plant cell and identify their functions. We select the hierarchical DAG pipeline, the interactive diagram template, and Gemini as the model. The system also supports OpenAI and open source models. The observability dashboard gives full visibility into the pipeline. We can see every agent across 6 phases. Click any node to inspect its inputs, outputs, and execution time, token consumption, and cost at tracked per agent. Each phase boundary has a deterministic quality gate. We can click on one to see the validation predicates it checked. All the phases passed. The game is ready. Let's play. Each game has 2 modes, learn and test. We start in learn mode. The first mechanic is drag and drop. We drag labels onto the plant cell diagram. Correct placements show correct feedback, and incorrect placement gives a hint pointing to the right location. Now the second mechanic, click to identify. We click on each organelle as it's described. Both mechanics in one game generated from a single question. And here are the results. Here is the game library with other game mechanics like sequencing, memory match, and algorithmic game mechanics like state tracer, complexity analyzer, and 10 others. To try GamED.AI, clone the repo and run the frontend. For full generation, start the backend with your API key and run from the command line.
Anyway, so the basic point of view is this: how can we have intersection of game, AI, and education together, and can we have more education content with the gaming beyond fun, so that it can be also useful in the way. So thank you everyone.